Right. So, let's see, we were talking last week about finding limits based on a graph, right? So you should be able to find one-sided limits. You should be able to find two-sided limits. Limits as x goes to infinity. You should know what happens when you approach vertical asymptotes. And then you should be able to do limits in reverse. Like if I said, find all the points where the limit is 4, you should be able to do that based on a graph. Any questions on those types of problems? All right, so today we're just going to talk about properties of limits. And the deal here is sometimes you might have more than one function, and they might be asking you a question about limits that involve both of those functions, or more than two even. Okay, so there's certain properties that are true if you're combining functions and calculating limits. So the first property is if you have the limit as x goes to a of f of x plus or minus d of x. So one function just added or subtracted from another. Then you could just like think of these as two separate limits that are added or subtracted. This is just going to be the limit as x goes to a of f of x plus or minus the limit as x goes to a of g of x. Okay? It might seem obvious, but I'm writing it down just so you have it. The same is true for multiplication. Like if I have the limit as x goes to a of f of x times g of x, you could just take the limit as x goes to a of f of x and multiply that by the limit as x goes to a of g of x. Again, hopefully that seems kind of obvious, but I'll show you in a second how the problems would actually look. It also works for division in most situations. Like if I have the limit as x goes to a of f of x over g of x. This is the limit as x goes to a of f of x over the limit as x goes to a of g of x. Now, under what circumstances do you think this won't work?
Zero.
Yeah, if the bottom limit ends up being 0, this obviously doesn't work anymore, right? So for limit as x goes to a of g of x not equal to 0, you can't divide by 0, obviously. Okay. There's a couple other random ones here. Like another one is if you have the limit as x goes to a of f of x raised to a power, any power, you really just take the limit of f of x and you raise that limit to that power. This is going to equal limit as x goes to a of f of x to the n. And you can kind of think of this as being like the multiplication one, like for lots of different functions, right? It's the same idea. If you have f times f times f, you can use this second rule to just, like, instead of this rule, but this just makes it a little bit easier. Just take the limit, like if it was cubed, you take the limit and cube the limit, that number, instead of cubing the function. Okay? Another one would be, there's two more. Another one would be you have the limit as x goes to a of a composition of functions, like f of g of x. This ends up being f of the limit as x goes to a of g of x. As long as f is continuous at that point. As long as f is continuous at that point, the limit as x goes to a of g of x, whatever that number happens to be, as long as that section of the graph, f, is continuous, is a continuous part of the graph. And then the last one is, this is the one that, in my opinion, is like the least obvious. If you take the limit as x goes to a of f of x plus b, this ends up being the limit as x goes to a plus b of f of x. And for this one, I think the best way to think about this is just think of like a horizontal translation. Like if I picture f of x, for example, suppose f of x, let's just use one that we kind of already know what it looks like x squared. Suppose f of x looks like this. All right? If you think about what f of like x plus 1 looks like, what does that look like in comparison to f of x? How is this related to that? No? 1 to the left, right? So this would look like this. 1 unit to the left, and then it's the same size and shape parabola. So if you just think for a second about what if we're trying to calculate the limit as x goes to 4 of this function, right? Well, that's going to correspond to the limit as x goes to 3 in this function, right? So what I'm saying is, if you were trying to calculate the limit as x goes to 3 of f of x plus 1, that's what I wrote here, right? The limit as x goes to 3 of f of x plus 1, it should equal the limit as x goes to 4 of f of x. Like those two limits are equal to each other. Just by the virtue of we have a horizontal translation, we're moving in one to the left. So it makes sense that to calculate the limit, you just move this one to the left, right? And you calculate, or one to the right, and you calculate the y value at that point. That kind of makes sense? Okay. So let me show you what these problems look like in Delta Math. They're going to give you the graphs of two functions, and they're going to ask you to calculate one of these limits. Like, for example, here's the assignment. Click on. Okay, so they're giving you two functions, right? F and G. And they want you to calculate the limit as x goes to -1 of f of g of x. So let me scroll down and then I'll write it. So we're trying to do the limit. Can I write this? That's stupid. Let me try again. I don't know why that's not letting me write. I'm perplexed. Let's just look at it. How about that? According to our rule, right, if I'm trying to calculate the limit, as x goes to -1 of f of g of x. If I'm trying to calculate this limit, according to rule number 5 up here, it's really just going to be f of the limit as x goes to -1 of g of x. This is equal to f of the limit as x goes to -1 of g of x. So if I look at g of x in my picture, this is g of x. what's the limit as x goes to -1? What is that limit? It's 0, right? Because it's the y coordinate of the hole. This is a hole in the function. We ignore that random point right there, right? The limit as x goes to -1 of g of x is 0. So up here, I'm just going to replace this whole thing with 0. It's going to be f of 0. So then I'm going to go to the function f, this lower function, and I'm going to calculate f of 0. As long as this graph is continuous at 0, which it is, right? There's nothing weird happening at that point. So the limit is just going to be the y value at that point. The answer is 1. Oh, let me draw.
Yeah.
Why didn't that let me do that before? I don't understand. Anyway, so the answer should be 1. I just typed in 1.
So what happens if there isn't like a continuous thing? You just say that's not exist?
They're not going to give you one like that.
Oh, okay.
But this can be generalized, actually. Instead of f of this, it's really like the limit as x goes to -1 of f of the limit as x goes to -1 of g of x.
So if there's a jump, then you just say that.
Yeah, yeah. They're not going to make it that complicated. Okay, so they're going to give you ones that are continuous at that point. Let's just try a couple more examples. So this one, oh, it's the same type of problem, so let me do a different one. Okay, so this one, they want you to find the limit as x goes to -5 of f of x cubed. So remember, the simplification of this is really just the limit as x goes to -5 of f of x, and then cube that. So what's the limit as x goes to -5 in this example? It's 4, right? Again, it's a hole in the graph, so it's the y coordinate of that hole. So this is just going to be 4 cubed, which is 64. So if you type that in, 64, and submit answer, that's the answer, okay? Let's do one more. Let's try one, that's another composition. Let's try one that's like this one. Okay, so according to our rule, this +1 can just be added onto that number. So this ends up being the limit. Instead of x goes to -2, it's going to be the limit as x goes to -1 of f of x. That make sense? So the limit as x goes to -1 would be 6. So that's the answer here. And again, if you want to, you can think of this as f of x minus x plus 1 is really just this graph exactly as is, but shifted 1 to the left. So if I'm trying to take the limit as x goes to -2 of that shifted graph, it's like taking the limit as x goes to -1 of the unshifted graph. You know what I mean? So you can think of it in those terms, or you can just think of this little shortcut that I just described. Does everybody understand what I'm talking about? So for all these problems, they're going to give you a sum or a difference or a product or a quotient or a composition or a power of a function like the one we just did, or something like this. And you just have to figure out the value of the limit based on the graphs that they give you, those properties. Questions? All right, that's it then. So the homework on Delta Math is just called properties of limits. Let's see.